Alright, so we've covered what a reaction is, how it shows the reactants becoming the products. You have an arrow in between them. We've talked about balancing reactions, or ensuring that the mass of the reactants and the mass of the products are the same. And we do that by making sure, every carbon atom that comes in comes out. Every oxygen atom that goes in comes out via like a counting method. So for the next several lessons, we're going to talk about different types or classifications of reactions, starting with combustion reactions. So for all of these, I want you to be able to identify what makes something a combustion reaction and be able to balance combustion reactions. So starting with what makes something a combustion reaction. So the rest of the reactions we discuss are going to be have fewer specific chemical requirements that have to exist in the reaction. So combustion reactions are taking a carbon-hydrogen compound and burning it in oxygen. And when you do that, you make carbon dioxide and water. All right. So anytime you've really seen burning, so having a campfire, or burning gasoline in a car, or burning fuel in a jet plane, these are all combustion reactions. All right. So you're going to have oxygen as one of your reactants, always. And then carbon dioxide and water as products. The only thing that really changes is the carbon-hydrogen compound that you are burning. All right? It's got to have carbon and hydrogen, because we're going to make carbon dioxide and water, but these values could be something like, it could be C2H6 or C10H20 or something like that. All right? It's not going, that is the only thing that really changes in this formula. Another thing that I want you to think about, and this is something that's consistent for combustion reactions, and just kind of what makes combustion reactions so useful, is think about it. If combustion reaction allows you to fuel and work a motor vehicle. If a combustion reaction is what produces this fire over here, what else is given off by a combustion reaction, even though it's not written into the formula? What do you think? What do we need to make an engine run? What do we need to produce that light and that heat? Hopefully you're saying something along the lines of energy. All right? Energy isn't a chemical. All right? If you remember way back to Unit 1, we talked about the difference between matter and energy. All of these chemical formulas represent matter. Energy doesn't get written in like a chemical, but most reactions either do give off some energy or absorb some energy. Combustion reactions are just known for giving off lots of energy. All right, so they are used to fuel all sorts of different energetic processes. So here is some practice for you. So if you remember, our generic formula for combustion is some sort of carbon-hydrogen compound plus oxygen making carbon dioxide and water. All right, so this left side, which one of these is the combustion reaction? All right. For me, I would go through and just look at my products. All right. No carbon dioxide and water. No carbon dioxide and water. That has carbon dioxide and water, so I'm going to keep C for now. Last one, no carbon dioxide and water. All right, and then if I move forward, I can see that the rest of this matches carbon-hydrogen compound and oxygens. So C. Try it again with the next one. Which one matches this setup? Carbon-hydrogen compound with oxygen making carbon dioxide and water. Pause it if you need some more time, but the right answer for this one is B. All right. So I know this one has oxygen in it, and it does make water, but we're missing the CO2 and then the C's in that formula. So that's why this one doesn't work. You're actually going to learn next group of videos what we call this type of reaction. So, and again, what is released even though we don't write it in the formula? Energy. All right, so balancing a combustion reaction. These tend to be along the trickier side, but only if you don't go into this with a plan of attacking your elements. All right, my hint to you when it comes to balancing a combustion reaction, deal with oxygen last. The reason for that is if you look on your product side, we have oxygen in 2 different places. I don't know where to start making adjustments to try to fix oxygen until I know for sure that at least I have my carbons and hydrogens right. So, deal with oxygen last. So, set up your tables and do your initial counts. All right. This is one, especially something this happens a lot with combustion reactions too. It might be easier to just write numbers, but I also have a hard time keeping track of things sometimes when I write numbers. So I'm gonna do the X's, but just keep in mind that, you know, as these get so huge, sometimes it does become easier just to write the number in the box. But I've got 1, 2, 3, 4, 5, 6, 7 carbons. 8 hydrogens, 2 oxygens, 1 carbon, 2 hydrogens, and how many oxygens? Look carefully. Yeah, we've got oxygen in 2 different places. We gotta count them both. We've got 1 here and 2 here for a total of 3. All right. So we're gonna deal with figuring out how to fix the oxygens last. So let's start with our carbons. All right, so I've got 7 carbons in my reactants, only 1 in my products. 7 times 1 gives me 7. So I'm gonna put a coefficient of 7 out front here. That's gonna turn this into 7, which is going to balance my carbons, but don't forget that 7 not only applies to the carbon, but also to the oxygen. So how many oxygens am I going to have now? Don't forget about this guy. There should be 15 now. All right, because 7 times 2 is 14, plus that 1. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yes, okay. All right. So, carbons matching. Let's fix hydrogens. All right, so I've got 16 on the left, 2 on the right. 2 times 8 will give me 16. So there's my 16. But remember, this 8 will apply to my hydrogens and my oxygens. So now, how many oxygens do I have total? All right, so 14 in the CO2 plus 8 in the water. 14 and 8 makes 22. So I currently have 15. Here's 16, 17, 18, 19, 20, 1, 2. So hydrogens matched up. Last thing. Is our oxygens. All right, we've got 22 over here and 2 on my reactant side. 11 times 2 will then balance things. All right, so that's going to make 22 over here. So, combustion reactions Sometimes you can get into some pretty big numbers, but if you remember to deal with oxygen last, they're really not that bad. So it's kind of like, oh, well, now I just have the total number of oxygens that I gotta make, so let's make sure I put enough in.